Hi guys, my name's Arminda King. I'm an AP Calculus teacher at Everest Public High School, and this is a video that talks about factoring before integrating. So look at this first problem here. We are taking the indefinite integral of the square root of x squared plus 8x plus 16. And right now, if I think about rewriting this as like the integral of x squared plus 8x plus 16 as a quantity to the 1/2 power, I'm going to have to do a lot of reverse chain rule stuff to integrate this. Like I could add 1 to this exponent and all of that, but then I'd have to divide by whatever the antiderivative of this is, and it would just get really, really messy. So one trick that you can use is very often you're able to factor the number that's, or the quantity that's under the square root. So if I take this and actually think of it as the square root of x plus 4 squared dx. And if you want to come over here and pause the video and try it out, you'll see that x plus 4 times x plus 4 does in fact equal this quantity under the radical here. Well, now this makes this a lot easier because the square root of something squared is just that thing. So now I just have x plus 4 dx. And this is very easy to solve using the reverse power rule. I'm going to add 1 to the exponents. This becomes x squared. And then divide by the new exponent, which is 2. And then the derivative of what gives you 4? Well, the derivative of 4x gives you 4. And since it's an indefinite integral, I need to include my universal constant. And there's your answer. And this works for trig functions too. So if you look at this one here, this might appear to be like pretty complicated, but actually if I just notice that I have a square under the square root, so this is like having cosine of x quantity squared dx. Well, the square and the square root kind of like cancel out. So this is just going to be the integral of cosine x dx. Okay, well I know that the derivative of sine x gives me cosine x. So my answer is just sine x. And then again, because it's an indefinite integral, I'm going to include our constant. Okay, last example here is a little bit more complicated. As you see here, I'm doing another trig function, but this time I have to the 4th power. Well, it's really important to remember that the 4th power is actually the 2nd power times itself. So in other words, I could rewrite this as, I'm going to keep the negative, cosecant squared x times cosecant squared x dx, like that. And when you look at it this way, what you see is I have actually cosecant squared x squared, because I have 2 of them. So I could also think of it like this. And now same thing, this square and the square root are going to kind of cancel out. And so I've got the integral of negative cosecant squared x dx. And now I'm going to kind of think back to my trig functions and derivatives. And if you remember that secant, tangent, cosecant, negative cosecant, cotangent, set this up. And the derivative of cotangent is negative cosecant squared. So that means that my antiderivative here is cotangent x, and include our constant for our final answer. Okay, so in summary, when you're taking an integral and you notice a square root after the integral, before you start rewriting it as a power to 1/2, think about factoring underneath the square root to see if you can simplify before you take the integral. It might help make things a lot more easy. Thanks for watching.